Section 4.1 and 4.2 involves classifying triangles and angles of triangles, finding the missing measures of certain angles and triangles. So we're going to begin with the basic things, parts of a triangle. And in a triangle we have three sides, of course, which means we also have three vertices. So the vertices are points A, B, and C. The sides are segment AB, BC, and AC. And then we also have three angles, which are angle A, angle B, and angle C. When we look at the parts of the triangle more specifically, this is an isosceles triangle because these two are congruent. In an isosceles triangle, we call the side that is not congruent the base, and the sides that are congruent we call the legs. And then we call this point that's opposite of the base or between the two congruent legs the vertex. In a right triangle, the side opposite the right angle is called the hypotenuse. Then these other two are just called the legs. The two that are on either side of the right angle are called the legs. There are two different ways that you can classify triangles, by their sides and by their angles. When you classify them by their sides, if all the sides are the same, then we call it an equilateral triangle. If two of the sides are the same, we call it an isosceles triangle. And if none of them are marked, we can assume that none of them are congruent. We call that a scalene triangle. When we classify it by its angles, if all three angles are less than 90 degrees, we call it an acute triangle. If there is a triangle with a right angle, we call it a right triangle. And if there is a triangle with an obtuse angle, then we call it an obtuse triangle. These are basic things that you probably already know, but we want to double check and make sure. Moving on to some examples. In example 1, it says find x and the measure of each side. So it says ABC is an equilateral triangle. As soon as you read that, you should mark that all three sides would be the exact same. Then we want to write an equation. Can you think of an equation? There are actually three possible equations, and what you want to do is just choose two sides to set equal to each other. Since they're all equal to each other, we're not going to set up 2x equals x plus 9 equals 3x minus 9, because then we can't solve that. So we only need to do part of it. So let's just get rid of one of the sides. We have these set equal to each other, and we're simply going to solve. So if I subtract x, I get x equals 9. Very simple. But it does say find x and the measure of each side. So we want to go and say AB equals, BC equals, AC equals, and find their measures. How do we find those? We plug them in. So if AB is x plus 9, 9 plus 9 is 18. BC is 2 times x, which is 2 times 9, which is also 18. And 3 times 9 is 27 minus 9, which is also 18. Now, it said that it was an equilateral triangle. So we know that we did this right because they all came out to be the same. That's why I put a check. Check. Yes, we got it right. Number 2, it says triangle JMN is isosceles with base JN. This is extremely important. If it says with a base or with the vertex, you have to make sure that you set it up appropriately. Otherwise, you're just guessing. So we want to draw our isosceles triangle, and it says the base is JN, so this must be J and N. If it says the vertex, it could also say the vertex is M. So if the vertex is M, then we put that up there, and these would be our two congruent legs. So it's very important you pay attention to that piece so that you can put these in the right place and mark the two legs congruent. Now JM is 2x minus 5. And Mn is 3x minus 9. Jn is x minus 2. So if these two are equal, we don't know anything about this one, but we do know that these two are equal. So we will set those equal to each other. We subtract 2x and we get x. we add 9 and we get 4. X equals 4. But we are not done. We still have to find the measure of each side, Jm, Mn, and Jn. So if x is 4, 2 times 4 is 8, 8 minus 5 is 3. 3 times 4 is 12, 12 minus 9 is 3. Sorry, 3 times 4 is 12, 12 minus 9 is 3. And Jn is 4 minus 2, 4 minus 2, which would give you 2. It did say this was isosceles, and these two came out to be equal, so we know that we did that right. Pretty simple so far. The next one was actually on our SLO at the beginning of the year. Some of you actually got it right. It says find the measure of each side of triangle DEC, then classify it by its sides. So we have this, you don't even have to plot it. We know we have a triangle, DEC. You don't even need to sketch a diagram for this. If you want to classify it by its sides, the length of its sides, then you need to actually calculate the length of its sides. So what do we use to find that? That's right, the distance formula. So remember, that is x minus x squared plus y minus y squared. So it should be subtraction in the formula. So I would like you and your partner to find the measures of the sides and decide how to classify it by its sides. So an equilateral, isosceles, or scalene. So go ahead and pause the video here and give it a shot. All right, let's see how you did. DE should come out to be 3 minus 9 squared plus negative 5 minus 3 squared. So this gives us 6 squared, which is 36. This gives us negative 8 squared, which is 64. So we get the square root of 100, which is, oops, just plain old 10. Sorry about that. DE, and then we have EC, should come out to be the square root of 1 plus 49, which would be the square root of 50. And EC, we've got DC is the last one. You do the whole thing. You get the square root of 49 plus 1, which is the square root of 50. Now technically you don't even need a calculator for this because we can tell the square root of 100, the square root of 50, the square root of 50. We have two sides that are the same. So what kind is this? It should be isosceles. We don't know anything about the angles. So make sure if it says classify it by its sides that you're not saying acute, right, or obtuse. All right, don't get your classifications confused. Next, we've got the triangle sum here, the triangle sum theorem. We've already discussed this previously, but we haven't actually written it down. If we have a triangle, it's asking what is the sum of the angles inside the triangle. The sum of the interior angles of a triangle is always 180 degrees. All right. An idea that you should be familiar with already. We're just making sure that everybody's on the same page here. The last thing, well, we're mostly going to find measures of angles on the whole backside. There's one other theorem that we need to talk about. But before we do that, let's see if we can find the measure of the missing angles. So we're trying to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. So we're going to combine together all the ideas that we know so far. First of all, triangle sum. If these two and this one make up a triangle, then the three of these should add up to 180. So these two add up to 110, and we subtract that from 180, which means angle 1 has to be 70 degrees. What does angle 2 have to be? It's got to be 70 degrees as well because of vertical angles. And we can use triangle sum again on this side. to find angle 3. So 70 plus 68, and we subtract that from 180, and we get 42 degrees. All right. So we're still using vertical angles. We might use linear pairs. We might use triangle sum. We will definitely use triangle sum. And then the other thing that we could use, so let's write those down. We could use triangle sum. We could use linear pairs, linear pair postulate. We could use vertical angles, are congruent. And then the last one we could use is exterior angles, exterior angle theorem, which I need to teach to you. And occasionally you might use some of your parallel line reasons. If parallel, then alternate interior angles are congruent. You might use one of those, including all of them, corresponding same side interior, alternate exterior. So those are all possible. So what is the exterior angle theorem? That's the only one that we are not familiar with. That's a new idea. Basically, the exterior angle theorem says that this angle on the outside, this is called the exterior angle. So when you, first of all, if you extend one side of the triangle, it creates an exterior angle. So there's another exterior angle right here, but we're just not concentrating on that one. There's also another one right here. So when you extend one side of the triangle, that will create an exterior angle. So the exterior angle theorem is saying that the measure of the exterior angle is equal to the sum of the two remote interior angles. So what does remote interior mean? Interior, we know, means inside the triangle. So we have three interior angles. And if you think of what remote means, if you go camping in a remote area, that is because it's far away. And if you think about why do we use a remote control to change the channel on the TV? Because we sit far away from the TV. So remote means far away. So if we're focusing on this exterior angle, these two angles are the far away interior angles, the remote interior angles. So if I add angle 2 plus angle 3, so these are your two remote interior angles. If I add these two together, I will get the measure of this outside angle. So oftentimes this is a little shortcut for us. You can, of course, always find this one by using triangle sum and then subtract from 180. But it ends up being exactly the same. So if you know this theorem, you can jump over that idea and find that right away. Sometimes this is the only way you can solve it if we've got x's in here and we're using expressions. So what I want you to do with your partner is go through, I'll do one of these with you and then you'll find the other. We're going to go through these and find the measure of each of the numbered angles using all of these ideas that we already know. So number 5, let's list out. We're trying to find angle 1, angle 2, angle 3, angle 4, and angle 5. So you don't always have to start with angle 1 if that's not the easiest one to find. But let's go ahead and start with angle 1 because it's going to come straight from our exterior angle theorem. Angle 1 is an exterior angle to this triangle over here. So I can very quickly find angle 1 by adding 50 plus 78. And when I add 50 plus 78, I get 128, and that's what angle 1 will be. When you're doing these, I would highly suggest you put the measures in the picture also, so that as you continue around the picture, you have those measures. You don't have to keep coming down and referring to them here. Just makes it a little bit easier. So if this is 128, how can we find angle 2? That's right, these two form a linear pair, so they must add up to 180. So 180 minus 128 would give us 52 degrees. I'm going to write 52 in there. Okay, so if we continue with angle 3, we can actually use our exterior angle theorem idea again. So 120 this time is the exterior angle, and the two remote interiors are angle 3 and this angle, which is 52 degrees. So that means that these two must add up to 120. So we can use the exterior angle theorem by working backwards. If I know these two add up to 120, then I could take 120 and subtract 52 to find angle 3, which is going to be 68 degrees. So we can use it by adding them together, or we can use it by subtracting one of them to get the other. If we know 120, then we should be able to find angle 4 very easily because we've got a linear pair going on. 180 minus 120 gives me 60 degrees. And so we got 60. And then we're going to use the exterior angle theorem one more time. We're trying to find angle 5. So we can simply add the two remote interior angles together to find this exterior angle. So 60 plus 56 gives me 116. So I would like you to finish doing 6, 7, and 8. Go ahead and list them out. See what you can figure out. 8 is somewhat tricky, so I just want to remind you that we have a large triangle going on here, a large triangle going on here, and then smaller triangles here as well. So it's usually the big ones that some people don't notice. So do 6, 7, and 8, and we'll go ahead and pause the video here, and then we'll see how you did. You need to add this measure here into, if it's not already on your notes, 69 degrees there, so you can find the rest of them. So go ahead and check it and see how you did. I'm going to highlight just some of the ones that are the most troublesome. Usually in number 6, there are no issues on 6, so you can figure that one out. But you're going to use exterior angles theorem, add these together to get this one. And then you can work in to find the linear pair of this guy. And do triangle sum here, and then you can do a linear pair here. So that's what we're doing there. Now in 7, you can find 1 because these are a linear triplet. They add up to 180. Once you know 1, you can do triangle sum. The tricky piece is 5 and 4. 5 and 4 are marked congruent. So if you know angle 3 is 116, then we just take 180 and subtract 116. And then whatever we get, we divide by 2 because these are exactly the same measure. So that is where we get 5 and 4 are both 32. So when you subtract this, we get 64, and we divide that in half, which gives us 32 for both of them. This one we can work in, linear pair to find 6, and then triangle sum to find 7. 8, angle 1 is really easy to find because you have this triangle right here. And then we've got, you can use your remote, or your exterior angle theorem then. So if you know angle 1 is 123, you can find this guy right here by taking 123 and subtracting 95. So you get 28. So these two will always add up to this exterior angle. So I can just take 123, subtract to get that guy, We can do the same thing over here, 123 to subtract and get that guy. That's not the only way to do it. You could also do these large triangles, 95, 24, and what will give you 180, and that can help you find 2 or 3. So both of those can use, there's another way that you can find that as well. If you have any questions, you can always rewind and go back.